Hey everyone, welcome to the final part of my VR hand tutorial series in Unreal 5. In this video, we will be building upon our hand systems from the previous two tutorials to create a procedural hand grip system similar to Half-Life Alyx. By the end of this video, you will have hands that utilize a line trace function to naturally conform around objects. I also want to shout out the virtual reality game kit by Deviver, as it was instrumental in my figuring this system out. This toolkit has an insane amount of interactions to get your next VR game idea started quickly, and I'm going to include a link to get it for yourself in the description and right here on the video as well. I would absolutely recommend it to anyone who is developing VR content in Unreal, and it is very worth the price for the amount of functionality included within the project. With all that out of the way, let's get started with the tutorial. In order for the hand to accurately conform around the mesh we wish to pick up, we first need to add functionality in our VR pawn so it can tell how close each finger is to the pickup object, and then stop the animations on the fingers at the right time. Navigate to your blueprints folder and open up the VR pawn, then go to the viewport. We want to select the HMD mesh and the right hand and turn them invisible. We are going to create spline meshes for each individual finger, and we have to create them for both hands. I will be honest with you, this process is going to be extremely tedious, but it yields very good results once it's over. First, navigate over to the Components tab and click Add. Then type Spline to get a spline component. Now, I accidentally created it on the right motion controller and we need to attach it to the left motion controller, so I will be fixing that now. Just click and drag it on top of the left motion controller to attach it. Then we want to rename the spline to L_thumb arc. Now select it, and inside the viewport we want to drag it up and out of the way of the hand so we can edit it. Navigate your cursor on top of the spline and right click. Then add spline point. We're going to utilize these to create the curve for our finger targets to follow. We simply need to calculate this point by point, and luckily I have already done this once, so I'm just going to put the values on screen for each spline point transform value, and all you have to do is copy the information on your end. Feel free to pause the video to add the values at your leisure. Before we get started on inputting these values into the spline, I actually wanted to show you how to navigate a spline component, because if you don't know, you're not going to be able to follow along with the tutorial. Essentially, the way a spline component works is it's a series of points that a line goes through, and we can actually go to those specific points that we're going to need to set in this tutorial by clicking on the points, if we wanted to click through them. But let's say we can't reach them or they're behind a mesh. The next thing we could do is we could press certain buttons on the right hand side here. So if you wanted to navigate to the end or the beginning of the spline, you would click these arrows on the far left and far right. So I'm going to navigate to the end of the spline by clicking this arrow. And then I can go back by clicking this arrow, but if I want to go one spline point at a time, because I have one in the middle here, I would click this innermost arrow, and that would navigate me to the next spline point. So just keep that in mind when I say go to the next spline point in a video. I'm saying either click on the next spline point or select an arrow. Every single spline point also has a input key value, and I will be referencing those input keys when I'm having you input the data. Let's navigate to the end of this spline. You should see that the input key says 2. We can now add the first of our values to start creating the proper shape for our spline mesh. Just copy and paste the values you see on screen. You will see that the end of the spline mesh conforms and moves to a different location. We can now do this for the rest of the spline component. Once you have finished, navigate to the left side of the screen and under Selected Points, click the furthermost left arrow and it will navigate back to the beginning of the spline. Here we want to copy the new arrive tangent and leave tangent values shown on screen. Once you are finished, navigate back to the Selected Points tab on the left and click the innermost arrow on the right. This will advance you 1 point forward and the input key should be 1. Now, just like before, copy the values shown on screen to their respective targets and just match them up. You have now completed the thumb spline. We only have 4 more to go. Navigate over to the Components tab and right-click on our L_thumb arc component, then duplicate it. Name this new spline component L_index arc. Now drag it up slightly to give yourself some space to input the new values. Right-click on the spline and add another spline point, since the fingers have 4 points instead of 3. Then we want to click on the first point in the spline, and the input key should read 0.0. Then, just like before, copy the values shown on screen to their respective locations. Once you are done with the first index point, click on the point at the end of the spline. The input key should read as 3.0. Now input the values shown on screen and you'll notice that the spline mesh is beginning to deform. But do not worry, it will take shape as we add more values. Click on the next point of the spline. The input key should read as 2.0. Import the values shown on screen. Now click the next value within the spine. The input key should read as 1.0. Then just input the values as they show up on screen. Once you have finished with all the input values for the spline points, your spline should look like this. Navigate over to the Components tab and click on the L_index spline. Right-click and duplicate it, and then name it L_middle arc, and drag it up to give us a little bit more room. We will need to tweak the values of the spline points slightly for all of our fingers. Select the first spline point on the middle arc, and the input key should read as 0.0. Then just input the values as they show up on screen. Once you have inputted the correct values, navigate to the Selected Points tab on the right side of the screen and select Next Spline Point. The input key should now read 1.0. Just input the values on screen like before. Then go back to the right side and select Next Spline Point, and the input key should read as 2.0. Input the values. Select the last point on the spline. The input key should read as 3.0. Then input the values on screen. When you have finished inputting the middle spline values, your L/middle arc should look like this. Navigate to the Components tab and duplicate it. Name this new spline L_ring arc. Then drag it up and follow the instructions on screen to input the values for the ring arc. When you are finished, your ring arc should look like this. Now duplicate it in the Components tab and name the new spline L_pinky arc, and then drag it up high. And follow the instructions on screen to input its values. When you are finished, it should look like this. Once you have set up your spline meshes for each of the fingers, navigate over to the Components tab and start dragging them over from the left-hand mesh to attach them. You will notice in the viewport that they snap to a different position. It will be easy for us to set them to the proper location on the hand. Once you've attached all the finger splines to the left-hand mesh, click the drop-down and close the hierarchy. The values should disappear. If they do not, drag them over the left hand again. Select the middle arc and navigate over to the Transform tab on the right side of the screen. I have put values on screen for you to copy over for the location, rotation, and scale. So do that as it comes up for all of the finger splines. You will notice that the finger splines will snap into place over the fingers. Once you are done with the middle, copy the values for the thumb. And then the index. And the ring finger. And finally, the pinky. When you are done, your splines should look like this. Now navigate over to the Components tab and select all of your finger splines and press Ctrl+C to copy them. Then turn the left hand invisible and select the right hand and turn it visible. Now right-click on the right hand mesh and select Paste. You will notice that all of your duplicated finger splines are all now messed up, but they are still not attached to the right hand mesh. With all the splines still selected, drag them over the right hand mesh to attach them. You'll notice that they flip into the perfect positions once attached to the right hand. Now we just need to rename our spline meshes to the R_finger arc instead of L finger arc. So do that, just right click on the splines one at a time and rename them. When you are done, they should look like this. Now we can start programming our procedural grip functionality. Now that we've set up our spline components, we actually need to create some variables. And the first thing I actually want to do is go to variables here, and in components I want to create a new variable. And I'm going to make sure that this is of type primitive component. So I'm going to type primitive component, and I'm going to choose object reference. And then I'm going to type right_primitive component. And then I'm going to do the same thing for the left, so I'm just going to duplicate this, just delete the 0 on the end, just like we did when we duplicated the splines earlier. left primitive component. And now that we have those, we're actually going to navigate over to the grab component because we need to add functionality for actually picking objects up and setting them. Before we leave the VR pawn, make sure you compile and save so we can access these variables inside the grab component. That way we can use the finger trace poser inside the VR pawn. So what we're going to do first is we're actually going to drag off the VR pawn, and we're going to promote it to a variable. Then I'm just going to set this to VR pawn. And now I can drag out to the end of right hand animation, and we'll just clean this code up real quick. Then we will compile and save. Now I can call variables from the VR pawn inside the grab component. The first thing we're going to do is we're actually going to go to the try grab function. At the very bottom here, you can see that we have free and snap, and those just kind of lead off into their own code sections. And what I want to do is if the user picks up any free object, we want to actually have it so that procedural hand code works. So what we're going to do is at the very end here, I'm going to actually drag off of the end of the snap function here. I'm going to type in switch controller hand. And then from there, I'm going to pull off at the green tab and type get hand from motion source. And then from that, I'm just going to type get motion controller. And then I'm going to go to the end of this free function here, because right now all it does is just select it as held, and I'm actually going to drag this to the end so it connects up into here. Now if you remember the last tutorial, we actually have already set up references to our left and right hand animation system. So what we're going to do is we're going to right click on the graph, and we're going to type get right anim, and grab that variable, and then I'm going to go to set object type, and for this we want to set it to basic, and connect that up to the right. And then from our setter node, we want to right click below it, and we want to get the attached parent. And then we're going to cast to primitive component. And then we want to grab a reference to our VR pawn. So just type get VR pawn. Now we're going to drag from that VR pawn ref we just made, and we're going to type set primitive. Scroll all the way to the bottom because we're looking for the variables we created. So we're going to grab this right primitive component, and we're going to plug the execution pin into the cast, and then from that, as primitive component, we're actually going to set our primitive component inside the VR pawn. Now we want to do the same exact thing on top, so just Control C and Control V this same code, and delete our getters and setters for the right hand. And so we're going to right click on the graph here, we're going to type get left hand anim and grab a ref to that, plug it in, and change this value to basic left, and drag that into left. And then we want to drag off from the VR pawn again. We're going to type set primitive, scroll all the way to the bottom, and get that left primitive component. Now we just plug that in like before. Now whenever the user picks up an object, it will set that object as the left primitive component inside the VR pawn. But we now need to go to the try release, and we want to unset those. Otherwise we won't be able to pick up new objects and have them conform again. So right click and get a reference to the VR pawn, and we'll start with the left hand first. We'll go set primitive, scroll all the way down, set that left primitive component. And so basically we're not connecting it up to anything. When you drop the object, we're just setting it to null. We're going to do the same down here, except with the right hand. Set primitive, scroll all the way down again, set that right primitive component, and set it to null. Now compile and save the blueprint. Navigate back to the main project viewport, and we need to create a new type of variable, and this is actually called a struct. So go to blueprints, and then at the very bottom here you see structure. So we're going to create a new struct variable. So we're going to type in here finger data, and then open that up, and we want to make sure that this is set to type float, and we need to create an input for each finger. So I'm going to click this 4 more times, 1, 2, 3, 4. So we have 5 fingers, and for this first one we're just going to call it thumb, and then the next one will be index, the third one will be called middle, and the fourth will be ring, and then the final one will be the pinky, last but not least. Now let's save that struct, and we're going to navigate back to the VR pawn so we can set up some new variables for our finger animation system. In the variables tab, we're going to want to click plus to create a new variable. And right now it's trying to make it a primitive component. And we actually want to click inside this little graph and search finger data, because we want to create our finger data. And we're going to call this right finger data. Then we want to compile it, and we want to make sure that all of those floats we just made are showing up in here. We want to make sure that this is set to a new category so we can organize it. And so I'm just going to call this procedural fingers. And pay no attention to if that's spelt wrong, because I genuinely don't care. Now let's go back to that finger data variable that we just created and duplicate it. And all we're going to do is delete that stuff on the end and go back to where it says that little R and change it to L. So now we have our left and right finger data, which we will use later. Then we need to create a few more variables. So the next thing we're going to do is we're actually going to create a vector array. So let's go back up to variables and press plus. And we're going to want to change this to type vector. And then right here on the right of that definer, we want to click on it and change it to an array. And for this first one, we're just going to call it right finger cache, and we're going to start with the thumb. And then we want to set that to our procedural fingers category. Now we need to do this for all of the other fingers. So let's do it. Duplicate this, and this next one can be the index finger. We'll duplicate that again, and this one gets to be the middle. And then we will duplicate that another time. And this one is going to be ring. Duplicate that a fifth time. And we'll call this one pinky. Make sure that you actually delete ring and then type pinky. I am just really bad at typing tonight, clearly. So we have them all for our right hand, and we need to do the same exact thing for our left. So click on that right finger cache thumb again and duplicate it. So click on that right finger cache thumb that we just duplicated, delete that stuff on the end, and then change the R to an L. So we have the left finger cache thumb. Now we duplicate that, change this one to index. It's the left index done, and then duplicate it again. Name this one middle. Duplicate it another time. And name this one ring. Duplicate that another time. And we're going to call this one pinky. Also, try not to not delete the word. So now we have all 10 of our finger cache vectors, and we need to create one more variable. And I swear, this is the last one we need to make for now. Make a new variable by clicking that plus icon and change it to of type integer. Change it back to a single by clicking on that little waffle. And we're going to call this finger steps. And we want to change that default value to 4. Then make sure you set that as part of the procedural fingers category. Now we need to create some new functions inside the VR pawn for our procedural finger code to work. So on the left-hand side here, we want to go to functions, and we're going to press plus to create a new function. And we're going to call this get finger steps. And we actually need to scroll down to the very bottom to where it says local variables, and we're going to create 2 new variables that are very specific to this function. The first one we're going to create is a of type float variable, and we're going to call this step size. Leave its default value at 0. Then we want to click plus on the local variables tab again to create another variable. This one will be of type vector, and we want to make that an array. Now essentially we're going to create a temp cache. So let's start by clicking on finger steps, and we want to create a new input. And this one's going to be a spline component. Type spline and then scroll down to where it says spline component and click object reference. Name this finger splines. And now we have this wonderful little input node. Now we want to drag off from our get finger steps input and type step size. Then we want to get a reference to our finger steps integer. So press get, and then type toFloat. Now we want to actually divide that. So just type /divide. plug that into the bottom, and then set this value to 1. And then plug that into the step size. Now we're going to drag off from the step size setter and create a for loop. Leave the first index set to 0, and then drag out another reference to our finger steps variable and plug that into last index. File and save. Now I want to go back to finger steps and press plus, and then just type relative point array. Change this to a vector and change that to an array. Now we can go and plug that in. And while we're here, we're actually going to scroll down to our local variables and grab a reference to our temp cache and plug that into the relative point array. Drag out a reference to our step size, and then right click on the empty graph and type multiply. Drag the step size into the bottom pin and the index into the top pin. I really do not like how the new math nodes look. They're very hard to read. Drag out from here and type clamp float. Leave the min as 0 and the max as 1. Now get a reference to our finger splines. Drag out and say get location at time. Plug the time into the return value. Keep that set as local. Then we want to drag out from that return value and type transform location. And then we want to get another reference to our finger splines. Then we want to get the relative transform and plug that into the T. And then plug that into the transform of the transform location. Now let's drag out another reference to our temp cache and then type add. Now plug the return value of the transform location into the bottom of that add. And then we connect the add all the way back up to the loop body. And let's just clean that up. Cool, that's the first function down, so compile and save. Let's go back to the event graph, and we're gonna wanna create another function. We're gonna call this one trace finger segment. Inside the trace finger segment, we're actually gonna wanna scroll down to the bottom first. Let's close the variables tabs just so it's out of the way for now. And we want to create some new local variables specifically for this function. First thing we're going to do is add a float variable, and we need to change that to a single and call this one total length. Then we need to duplicate that, and we want to just call this one hit length. And then we want to duplicate that one again, and we want to change this one to actually a Boolean variable and call this one did hit with a question mark because it's a Boolean. And we want to duplicate that again, and we want to create a vector node, and that will be called temp A. And we want to create the same variable, duplicate that one more time, except call this one temp B. Click on that trace finger segment, and we want to add a few new variables here as well. So the first thing we're going to do is add a point array. And this is a vector array, so call it point array. And make sure that you spell array right, otherwise people will be mad at you. Then type grab component. And then set this to a single, and we want it to be a primitive object reference. Press plus again. This one will be called the hand, and that one will be a scene component, and that one is also just an object reference. For the outputs, we just want to create another float and call it alpha. Cool. Let's disconnect that because we need to add a lot more code in here. Start by dragging out of the point array and then type last index. Type minus to get a subtract node, and then we want to subtract that by 1. Now drag out from the execution pin on the trace finger segment and create a for loop, and drag that -1 into the last index. Grab our return node and plug the completed into it. Then drag out and create a clamp float. Min should be 0, max should be 1. Drag out of the value, and then type a slash to get a divide. And we want to grab our total length and our hit length. And we want to divide our hit length by our total length. This essentially helps us figure out where the finger animation is supposed to stop, like lock up, inside the animation blueprint. Now we want to create two setter nodes. Set our temp A, set our temp B, connect them up to each other, and then connect those up to the loop body. We now need to define these two. So what we're going to do is we're going to drag out from our index, and we're going to do a plus integer, and we're adding 1 to this. Let's also just clean that up real quick so it kind of looks nice. Now we want to get a reference to our point array and drag that out and type get a ref. Connect that up to the integer. We want to just copy and paste that and connect it right back up to the point array and to the integer. I forgot to connect this. Once we have created those get array refs, we're actually going to go back to our trace finger segment input and drag out from the hand. And here we want to get world transform. And then we want to drag out from the get and type transform location. And then just grab that, copy it, and paste it up top, and connect this one to that top get node. Now collect the get world transform to both of those transform nodes. And then we want to drag our temp A and B out more. And the top one goes into temp A, and the bottom one goes into temp B. Now we want to drag off of temp B and create a sequence node. Drag off of that sequence and create a branch. And we want to grab our did hit boolean and plug it in. Now we want to go all the way back to the beginning of our function and drag out from our grab component. Drag that all the way to the end. And then create a line trace component and connect that up to the false pin of the branch. Now we want to grab a reference to our temp A and our temp B. Plug the temp A into trace start and the temp B into trace end. Drag off of that and create a branch. Connect the condition to the return value of the line trace component. Drag out of the out hit and create a break hit result. And we're actually only looking for distance out of here. So drag out, press plus so we can get a float, and then connect it up to the bottom. Then we can close this back up again. And then we want to grab our total length and add it to the distance. And then we want to drag out of the true pin and set did hit. Set that to true. And then we want to set the hit length. And connect that up to the added total length. Go back to our sequence node and drag out and type set total length. Drag out of that and create a branch. Pull out our did hit boolean and connect that to the condition. If it's false, we want to set hit length. And drag off of that and type total length. Drag off of that total length setter and create a plus float. And we want to get another reference to our total length. And then we want to drag out our temp A and temp B. Drag off of that bottom pin, create a distance vector. Plug temp A into V1 and plug temp B into V2. And that is all we need to do for our trace finger segment function. Now that we have set up our two main functions for getting the finger animation data, we can actually go into the event graph and create the main functionality for our finger animation data. Instead of doing this in the event graph, I actually am going to create a new graph. So go over to the left where it says graphs and press new. And we're going to call this finger animation graph. Now we want to open that up. And the first thing we want to do is add a new custom event. So type add custom event. And we're going to call this setup finger anim data. Now I want you to drag out from this and create a sequence node. Another cool way of creating a sequence node, if you didn't know, was just pressing S and clicking on the graph. We actually needed to do this anyway, so create another sequence. And for this one, we need to make it have 9 pins. So click until you have 9 pins. What we're going to do essentially is we're going to cache the splines and then delete them. So we're going to do the delete spline code first. Pull out of the then one and type destroy component, and it's just going to like grab something random, so you can get rid of that. Now go up to the components tab in the upper left and select all of our splines. And we want to go to the right hand and do the same. I really hate that these are not organized like by name. So I need to make sure that I'm grabbing all of them. I should have 10 splines. So we have 10 splines here. And what we're going to do first is plug them into this destroy component. Plug them all into the destroy component. Now we want to grab these and copy paste them. And I want to organize these better. So I'm going to grab the right thumb, then I'm going to grab the right index, then I'm going to grab the right middle. And then I'm going to grab the right ring and drag these all down. Grab that right pinky as well. Then I'm also going to go thumb, index, middle, and pinky. The reason that I'm organizing them like this is because I want them to match the finger data struct. It just makes it easier for our coding purposes. So let's start by dragging out from our right thumb arc and type get finger steps and plug that into the then 0. Let's just drag that directly beneath it. Now scroll over to the variables tab, and underneath our procedural fingers category, we want to grab the right finger cache thumb and set it and connect that up to the function. Now we're just going to duplicate this, and we're going to do the exact same thing for the index. We're going to set that, and we're going to plug that in. Then we want to plug our index arc into finger splines, and we want to connect that to then 1. And that is our other function. Now repeat these same steps for the rest of our finger splines. Alright, and there is that custom event done. Now we're going to actually set up the functionality that sets these float values inside of the VR pawn. So we're going to create another custom event, add custom event, and I want to call this one right trace finger data. Just to get out of the way, we're going to add another custom event and call this left trace finger data. And just drag this out of the way for now. And we're going to go into our components tab and scroll to the very bottom, grab our right primitive component, and we want to check if it's valid before we do anything. Is valid. And plug that execution pin into our new custom event. And then from there, we're going to create a new sequence. And then we're going to create another sequence. This one gets 4 pins. What we want to do from here is actually drag out a setter node for our finger data, and then we want to split the struct pin. And what we're going to do is we're just going to connect this up for now and drag it over here. This is our endpoint. We have to code everything in between here. Now, let's get a reference to the right hand. Just grab it and drag it out. Drag out from then 1 and type trace finger segment. And grab that function. What we're going to do is then drag out of this primitive component, and we're going to create a reroute node. Because I'm lazy. Then Then we're going to grab this and paste it. We're going to grab these two and paste them again. And then we're going to just paste one last one down here. So we have 5. Now we need to go and we need to grab all of our right finger indexes. So right thumb, right index, right middle, right ring, and right pinky. Now plug them in this order. Thumb goes to the first one, index goes to the second one, middle goes to the third one, ring goes to the fourth one, and pinky goes to the fifth one. Now we need to connect our right hand to the hand pin of every single one of these. So connect that up as well. Don't forget the pinky or the ring finger. Then we want to connect this grab component to the grab component pin. So let's connect that up as well. And it makes sure that you don't miss any of them. Okay, that seems to be the proper working order. Just to make this look a little bit more attractive, what we're going to do is make these look better. And then we just plug the alpha into the corresponding finger. So since this top one is thumb, we plug it into thumb. The second one is index, which goes to index. Third one is middle, which goes to middle. Fourth one is ring, which goes to ring. And fifth is pinky, and that, of course, goes to pinky. Then also on the sequence, connect that up to all of these nodes as well, or the code will not run. Forgive me, I like to get ahead of myself. Now we can copy all of this code and go down to our other function and paste it. And now we need to replace every single reference to the left hand with our right-handed references. Let's start with the primitive component. Grab the left primitive component from the variables tab and drag it into that isValid node, and then connect it back up to our reroute node as well. We should have done this for the right hand as well. Now we have to reconnect it back up to all the nodes. Go up and grab our left hand, and then plug it into the hand pin on every single one of these hand refs. Now we need to delete the left finger cache ones, and we need to drag out the right finger cache ones. Drag them out in order of thumb, index, middle, ring, and pinky, because they need to line up perfectly. Drag the thumb to the top, index to the second, middle to the third, ring to the fourth, and pinky to the fifth. And then we have to replace this node with our left finger setter. So find our left finger data node, press set, and split that struct pin, connect that back up to the execution pin, and then thumb goes to that top thumb, index goes to that top index, middle goes to middle, ring to ring, and pinky to pinky. Let's check our code and make sure that everything is set up correctly. We have all left-handed references, and then we have all right-handed references for both hands. Now that we have set up the setup finger anim data and the setup trace finger data, we need to set it up so these events are actually called. For the first one, we actually just go to the event graph. Right here at the event begin play before our VR hand animation setup, drag out, and just type setup finger anim data. Then we want to go to the grab component, and we specifically want to go into the try grab function. Right after we set these primitive components, we actually need to call the trace finger data so it sets the values properly. So drag out from VRPon, since this is the left hand, we're going to try left trace finger data and plug that in like so. Just double click and reroute so it looks pretty. And then from the right, we do the same thing. Just type trace finger data, grab the right trace finger data, plug that in, create a reroute node, drag it up so it looks nice. Now that we have set up our functions to work, we need to go into our BP hand anim and set up the final animation code to make these procedural grip animations actually work. Navigate to where you imported the mesh and created the blueprint in the first tutorial. Mine's located in QKVR assets and inside hands. Double click to open that up, and the first thing we're looking for is actually the event graph. Now what we want to do is drag off of the left hand anim, and we want to create an AND boolean. Then we want to grab our object type variable in the lower left and drag it out. Just press get, Drag out from our object type and type equals equals and select equal enum. Now we want to set this to basic left. Since this is on the left hand, we want to make sure that the object is a base of type basic left, which we set up earlier. And this is the condition for the function we're about to set up. Go down to the object hold setter, drag off of it up top here, and create a branch. Connect the code we just did to the condition of that branch. Now we want to go all the way back to the VR pawn, and we want to get the left finger poser data. So get the left finger data. And I just realized that I forgot to do one thing before we got started with this. And that is we actually need to go into our variables tab, get the struct pin for our finger data. We need to create a variable for both the right and left finger data struct. Click plus on the variable, and then type left finger data. And then the variable type, we're gonna open it up and type finger data. Make sure that our float values are showing up there. And we wanna drag that out, press set. Now plug that left finger data setter we just set into the getter from our VR pawn. Basically, this is gonna take the values we set with our trace finger functions in the VR pawn and set them inside of the animation blueprint as well. Finally, drag out from the true pin to the left finger data setter. Now we need to do the same thing for the right hand. I also just realized we're dragging out from the right thumb anim. We actually want to be dragging out from the left grip anim instead. So make sure that the left grip anim is going into the and boolean and not the left thumb anim. Drag out from that right grip anim, type and. Then drag out our object type again, type out another equals equals, set that to basic this time instead of basic left, and then we want to just plug that into the other part of the and boolean and just make it look semi-pretty. It's not going to look pretty no matter what you do because it's blueprints and they're just ugly. Then off the object hold, drag down and create another branch. Connect the and up to that condition. Then from the VR pawn, we want to drag out. Try not to drag the entire VR pawn with you. We want to type get right finger data. And then we need to create another variable for our right finger data. So just duplicate our left finger data variable, delete that stuff at the end, replace that L with a capital R, drag it out, press set, connect it up to the true and the right finger data getter from the pawn. Now we need to go to the animation graph. Click into hand animations, go down to our object state. For now, we want to disconnect our grip pose system because we're going to create new functionality in here and then create a system that blends between the two of them. Let's actually do that right now. Drag out our object type enum, press get. We're going to drag out of here and we're going to type blend poses by enum object type. Drag that into the active enum value. And then inside of here, we need to right click on there and you want to create one for basic and basic left. Reconnect our grip pose system to the default pose, connect that up to the output animation pose, and now we're going to create our procedural hand system by using the finger float data that we create in the VR pawn. Before we do that, we actually have to go back to the animation graph, and inside the animation graph, we need to create two cached poses. A cache pose is essentially something that we can reference multiple times without having to pull it out of the asset browser. But we're going to have to pull it out of the asset browser for the first one. Pull out this QK anim stretched, and then pull out the anim QK grip. Drag out from the QK grip and type cached pose to create a new cache pose. Click on that. In the upper right corner, we got to name it something different. We're going to call this procedural grab, and then we're going to drag out from the QK anim stretched. We're going to create another cached pose. Click on that, and in the upper right corner, just save this to stretched position. Save it to stretched pose. Now we want to go back to our object state, and you can see that little tab up here. Just click on that, and I'll bring it right back in. And what we need to do is actually get those two cache things we did. So just type just type procedural for that first one, and it'll say use cache pose procedural grab. So grab that one, and then we also want to do our stretched pose. So just type cached stretch. And here is where it's going to get slightly complicated, so try and pay attention to the best of your ability. The first thing we want to do is bring that stretch pose on top. And we want to drag out of it and type layered blend per bone. We need to add a few new blend pins. To do that, you just right click on it and scroll down to the bottom and type add blend pin. And do that until we've got 4 blend pins, 1 for each finger. As you can see, we now have 5 options for each of our fingers, and we're gonna use the finger data struct to actually set this up, just like we did for the finger struct data. Inside of the layered blend per bone, under layer setup, we're gonna open all of these indexes, and each of them have empty branch filters with 0 arrays. Let's add our first one. Open that up, and we wanna type the bone name of that first bone. The name of this first one is actually our thumb underscore 01 underscore right bone. And this is case sensitive, so make sure that you spell it correctly. Just to save ourselves some time, we're gonna Control C, and we're gonna add another branch filter. And here we're gonna paste that in again, except this one will be index. And make sure that it's lowercase and spell it exactly like the bone is spelled. If you're unsure of how the bones are spelled, just go ahead and click on the animation skeleton, and you can actually see the bones. We're blending the first bone in every single one of these fingers. So thumb 01, ring 01, pinky 01, middle 01, and index 01. Let's go back to the BP hand anim, and let's keep inputting those. So this next one will be middle 01, add another one, open it up. This one will be ring. And again, make sure you're spelling these correctly or it will not work. And then finally, we want to do pinky. Cool. Now you can see this procedural grab pose. We're going to paste it multiple times and set it up so it looks all nice and pretty. And plug it into every single one of these blend poses. That base pose stays plugged into stretch, and this procedural grab goes into all of these base poses. Now, the way that we set the blend weights is we actually drag out our right finger data, and we're gonna split that struct pin. Thumb goes to that first one, index goes to that second one, middle goes to the third one, ring goes to the fourth, and pinky goes to the fifth. And then we're gonna plug this one into the basic pose. Rad. Now, you're gonna love this. We just grab this entire function, Control C, Control V, and the only thing that we have to replace is the left finger data. So say get left finger data, split that struct pin, and plug those all back in just like they were for the right hand, except now it's for the left hand. I would recommend commenting these so you know which hand is which, but for this tutorial I'm not going to do that because it's kind of a waste of time. Once we have that all set up, we just need to test it. You are now able to pick up objects and your hands will conform around them accurately. That is all for this video, and this is the end of my VR hand tutorial series. I want to thank you for watching, and I urge you to subscribe to my channel. I will be working on more tutorials in the future centered around VR development and game design. So if you have any requests, please let me know in the comments section. I want to give an extra special thanks to my patrons for their continued support. You guys motivated me to make this series in the first place. I'll see you in the next one.